Okay, let's welcome the first speaker of this session. It's Arif. He's working for the Fachhochschule in Berlin. Next to that, he also still works at ThoughtWorks, a company many of us know because of their groundbreaking work in the area of data products and data mesh. And today he will share with us his findings and approach, I guess, and the problem that he has studied in his paper on data mesh to Intermesh. That sounds like a very appealing and interesting new concept. A platform-driven approach to govern inter-organizational data sharing, which I know from my own experience, it's very, very tricky. So very curious, and the floor is yours.
Thank you very much.
Awesome, thanks a lot. Yeah, it's my pleasure to be here. I only have 15 minutes, I think, so it's barely enough to read the title. What do I want to tell in those 15 minutes? First, I want to look into what makes data mesh successful within a company. Then I want to put a spotlight on federated computational data governance, which I think is one of the most important and interesting topics of data mesh. Then I want to pose the question, what is different with inter-organizational data sharing? And then we'll have a look how we can apply the principles of data mesh to inter-organizational data sharing. First of all, a few words to myself, or about myself. My name is Arif. As was said just before, I used to work full-time with ThoughtWorks. In fact, I was the head of data and AI for ThoughtWorks Germany. And I was in that role right at the time when Zhamak Dehghani in the US was coming up with the data mesh concept. So that means, yeah, we were in close contact, and I got early access to the draft and gave feedback and so on. And that means I was one of the earliest persons to be exposed to this. And in fact, that also has led to me basically doing, at least on the industry side, basically only data mesh since then. Because data mesh was such a hype that all the other topics that I used to work on just vanished, and it was all data mesh transformation, consulting, etc. But in 2020, end of 2020, I kind of quit industry and took a professorship at HDW Berlin. I do continue to work with ThoughtWorks and also as an independent consultant, but only as my side job, so to say now. So we have seen that exact graphic actually this morning, and as said, I was involved quite early on. I managed to publish that book here with O'Reilly even before Zhamak was able to publish her, but honestly, although it doesn't look that way, mine is actually much smaller than hers. Anyway, I wanted to come back to this slide here, which Simon already showed this morning, because I think it really nicely shows what really the problem is that we're trying to solve with data mesh. And that is a problem with scale, right? So we see that before data mesh, when we scale up the data usage and the data production, etc., that at some point, there's some connection issue with the mic, that at some point, when we go further in the scale of data consumption and data usage, then we actually see a decline of business impact. And I've seen that hands-on. Means I have been doing consulting work with companies where literally nothing was moving anymore. So they were very ambitious in terms of data analytics, but they basically reached almost like rock bottom there. And that is really what we try to solve with data mesh. Now, it will take probably an hour to explain how data mesh solves that, but here's my take. What is really the key idea of data mesh to solve that scaling issue? And that is that data mesh reduces bottlenecks and inefficiencies by moving the ownership to where the expertise is, right? And that means Now the domain experts who really understand the data, they take responsibility about the shape and the quality of the data. And it's not some central data team with people who are good technologists but have no idea about the domain, right? That take care of the actual ownership of the data. And instead, those technologists, like data engineers, they focus solely on building a domain-agnostic self-service data platform that enables those domain experts, right? So the idea is that we give a lot of responsibility to those domain experts, but that also means we have to support them, right? Because otherwise we just bury them in more responsibility. And this is exactly this idea of a self-service data platform that enables those domain experts to basically do their job. And we call this a shift left, right? And this shift left of responsibility that allows us to do kind of a responsible decentralization, where we decentralize the ownership and the responsibility about the data and the data quality away from a central team, without actually risking that nobody is responsible or nobody is able to fulfill this responsibility. Now, as said, I wanted to focus on one specific topic, and that is data governance. And I wanted to focus on that shift left that I just mentioned in terms of data governance. So data governance, as I see it here, is really mostly about mitigating risks when it comes to data, in terms of data leaks, of course also to some degree data quality, but there's a lot about policy, compliance, etc. And one of the key components of data mesh, or the key principles, is what is called federated computational governance. And that means we want to federate governance, which means we want to give responsibility about governance topics to the people who own the data and who understand the data. So this is this decentralization and federation part. But we want to help them with computation. That means we want to give them a way to decide the important things that they know about, but at the same time want to automate as much as possible with those decisions. What does that mean? So it means when we go from a pre-data mesh situation of data governance to a federated computational governance, it means that we go away from a centralized team to a federated team. And we're in a pre-data mesh situation. The central data team was responsible for data quality. Now the central data team, or the central governance team, which may still exist, is only responsible, for instance, for defining what constitutes quality, right? Basically, for instance, are there specific quality levels that have certain consequences, etc. And then leave it to the domain experts to assign those levels. The same is true when we look at security. So for instance, here in a federated computational data setup, we let the central governance team only define aspects of data security, for instance, sensitivity levels, and then build that into the data mesh platform to let automate as much as possible. We also, maybe a little bit in between. So when I joined HDW as a professor, of course, because I was doing so much data mesh in the industry, I thought I also want to do research now on data mesh. And at the time in 2020, there was basically no academic work on data mesh at all. And I found the data governance part the most interesting part, and so I started with this paper here. Then moved even further into automating federated data governance, and then just published this one together with Simon. So this is what Simon sneak peeked this morning, how to use AI. And then this is the paper that I'm presenting today. to move from within an organization to inter-organizational data share. So, how does this computational data governance look like? And let's take this example from with those sensitivity levels, right? So the idea is that we have this central governance team up here, which still exists, but now this central governance team only defines those global sensitivity levels, and those sensitivity levels, they can be used by all data products, right? And so that means the people who own those data products here, the domain experts, they now use those sensitivity levels to tag the output ports of their data products accordingly. Because they know best what is in their data, right? And they know best if there is PII in there or whatever. Now, as said, we want to enable and help those data owners as much as possible. And that means the idea is that the central governance team works as closely together as possible with the people developing the data mesh platform. And the data mesh platform provides tools that make it as easy as possible for the data owners to tag their data accordingly. All right, so this is the one thing, how we support the data owners. But then, talking of computational data governance, we try to automate as much further as we can. So for instance, we can say, well, if we see that this output port of this sharing data product here is tagged as PII containing, and we see that this consuming data product is consuming from this output port, and both data products run on the same platform, then we can first infer and say, okay, then probably this data output port, or maybe this output port is also sharing PII information, right? And we can set this as a default. And then the people owning this data product, they can maybe say, no, we're filtering out all the PII data, and so we declassified it, right? But we can even go a bit further, and we can go in the direction of contract verification and contract monitoring. And this is what I want to focus on here, right? Because to me, besides this shift left of responsibility, it's really the composition of data products that is the key enabler, right? We want to get to a situation where we get to a network effect, where we can easily and safely compose data products to achieve bigger results, or bigger, create bigger value. So as said, I want to look a bit deeper into this contract testing thing. And there's something from the service community that is around for quite a while now, that is consumer-driven contract testing. Mainly comes from the microservices community. And that can be applied fairly well, or fairly one-to-one to data contracts as well. It means that we have a sharing data product. This sharing data product on their output port defines some service level objectives, and the consuming data product publishes a data test. This data test manifests their expectations towards the data, quality aspects, etc. And this should hopefully match with the SLOs that the sharing data product is publishing. And now we use the mesh platform to execute those data tests as part of the CI/CD pipeline of the sharing data product. That means basically when the sharing data product is deploying a new version, and then this new version is tested with all the data tests of all the consuming data products. And if any of them fail, then we know that with this new version, the sharing data product has broken some of its downstream dependencies. And then we can roll back, etc. Right? So this is actually not very new, this concept, and can be applied fairly easily. Now, what's different with inter-organizational data sharing now? Well, first of all, there are, as we heard several times this morning and over the entire day, there are different ideas of data products, there are different implementations of data products. So, external data products, it means data products that we want to share outside of an organization, must be shared in a standardized way. And then, whereas within one organization, we have some level of trust, some implicit level of trust that we all want to achieve the same thing, right? We don't have this level of trust when we share data across organizational boundaries, right? And that means that consumer-driven contract tests that I just showed, they are basically not enough, and I will go into this in half a minute. And then, finally, and of course this list is not complete, we have no shared data infrastructure platform. And this poses the question, how can we check guarantees about data, data quality, etc. across organizational boundaries and across different data platforms that are being used? So let me start with the middle point. As said, with consumer-driven contract testing, this is basically not enough anymore, especially not if we deal with sensitive data. Because with sensitive data, when we share sensitive data here, it's not enough anymore that there are requirements that come from the consuming data product, but now we also have requirements or constraints that come from the sharing data product. So for instance, we want to say, you can have this data, but only if you properly encrypt it, or if you only reshare it further under these conditions, right? And this is why we have to extend this from a consumer-driven side to a sharer-driven side, and add expectations here to this on the left side, on the sharing data side, and add assertions on the consuming side. And those assertions we can usually define as a relation between an input port of the consuming data product and an output port of the consuming data product. Now, by the way, we're still within one organization now. We want to also automate this as much as possible, right? So now we also want to automatically check whether the promises that a consuming data product makes that hopefully match the constraints that a sharing data product states, that they actually hold, right? And we can do this by using a constraint verification library, for instance, that automatically checks if those constraints actually hold, because we're all running on the same platform. And so the platform is in control of the data. Thank you. Now, and that's actually, I think, my last slide. Now, what happens when we go to inter-organizational data sharing? The problem here is that we don't have one underlying data platform, right? Data mesh platform. But we have multiple data platforms in each organization. And basically the most straightforward idea that we came up with is to say, well, if we have such a constraint verification library in one of those platforms within one company, then maybe we can certify that library or even certify the entire data mesh platform with a third-party certification provider. And this way, basically then extend our sharing constraints in such a way that we say, we have these constraints, but we can only share it with a data product that runs on a data platform that is also certified in such a way that it can automatically verify those constraints. And with that, I come to the conclusion, or the summary. So basically, within organizations, data mesh improves efficiency through decentralization and automation. When applying data mesh's approach to inter-organizational data sharing, the lack of trust and shared infrastructure calls for cross-organizational standardization. Now, I think the interesting point that we came up in this paper is that instead of focusing on data product standardization, which we see a lot of initiatives about, maybe we should focus on standardizing data mesh platforms and the capabilities that those data mesh platforms provide, so that we can enable those kinds of automations across organizations. And I thank you very much. I think we have no time for questions today, but I'm more than happy to answer any questions in the poster session on Friday. Thank you.
Actually, I think we have time for one question.
More than
since Indika will, I guess, come here now and install his laptop. So can you come over, Indika? Then, so we could take one short question while Indika is getting ready for his presentation. It's a very surprising topic he will share with you today. It's about LLMs and service-oriented architectures. So, but is there any question for Arif?
No questions today. And as I said, more than happy to talk in the coffee break and also in the poster session on Friday. Thank you very much.
Thank you.